Okay, students, now let's have a look into the second case in which we have to find the partial fraction. So, in the second case, it said that proper fraction with repeated linear fraction factors. So, now in the denominator, we have repeated factor. So, for example, px plus q divided by ax plus b whole square. Now, ax plus b whole square clearly means that it is ax plus b into ax plus b. So, there are two factors, but both the factors are linear and both are same. So, the partial fraction is a over ax plus b over ax plus b whole square. So you can see that here we have this factor without square and then the factor with square. Let us take an example here quickly. If we have something, for example, 2 over x plus 1 plus 5 over x plus 1 whole square. So you can see that the least common multiple of these two denominators is x plus 1 whole square. So if there is a square linear factor in the denominator, its partial fraction include two factors or may include two factors. So we should not ignore that. One factor is without the square and the other factor is with the square. As you can see here, this is x plus 1 power 1 and this is x plus 1 power 2, but the least common multiple is x plus 1 whole square. And then you solve it to simplify the expression. So once you do the reverse process, this thing will have these two factors in the form of partial factors. Okay. Similarly, if we have something like that, in the second case, the more extended form, px plus q divided by ax plus b, one linear factor, and then cx plus d whole square, there is the repeated factor. So one linear factor which is different, and then there is a repeated factor. So the repeated factor will be using this rule. You can write down this as a repeated factor, partial fraction of repeated factor, which is b over cx plus d plus c over cx plus d square, one with the power 1 and one with square, and this one, then remaining part, a over ax plus b. So there will be three factors now: a over ax plus b, b over cx plus d, and plus c over cx plus d square. So these are the possibilities, and if there are more factors in the denominator, you can expand it accordingly. Let us have a quick look into an example here. So express 2x minus 1 over x minus 4 whole square as in partial fraction. So clearly this is the case which we have discussed right now. There is a square in the denominator, so this is the case of a repeated factor in the denominator. So a over x minus 4 without square plus b over x minus 4 with square. So first of all, again, get rid of the denominator, multiplying each and every term by x minus 4 whole square. You will get 2x minus 1, 2x minus 11 is equal to x minus 4 is in the denominator, and when you multiply it by x minus 4 whole square, you will get x minus 4 in the denominator, and here x minus 4 whole square multiplied by x minus 4 whole square in the denominator cancels out. So this is our equation in the simple form. Now you can see that there is only one factor in the denominator, which is x minus 4. So if you say x minus 4 is equal to 0, so x is equal to 4. So when x is equal to 4, putting x is equal to 4 in equation 1, we will get the value of b, which is equal to minus 3. So this is one value. Now because there is no other factor for which we can get a value of x and then insert it in equation 1, we take 0 then. So put x is equal to 0 in equation 1. Once you put x is equal to 0 in equation 1, value of b is already there, so you can get the value of a, which is equal to 2. So we found the values of both of our variable a and b. Therefore, 2x minus 11 over x minus 4 whole square is equal to 2 over x minus 4 plus minus 3. So it is minus 3 over x minus 4 whole square. This is our required answer. And if you solve this one by taking the least common multiple here as x minus 4 whole square, you will get back this fraction.